Hi, in this video we are going to talk about arrays in Java, so let's get started. I'm going to create a distinct package with the name arrays, and I'm going to create a new class with the name application or just app.java. I'm going to create the main method, so the public static void main with the string args. And basically I'm going to create a one-dimensional integer array, for example, for storing numbers. And as I said earlier in the theoretical section, if I try to instantiate the array like this, Java is going to tell that variable must provide either dimension expressions or an array initializer. So we have to tell Java that how many items we are going to store. And that's why I said in the theoretical section that arrays are not so dynamic in the sense that we have to specify the size of the array at compile time, that how many items we would like to store. For example, I would like to store 5 integers. Basically, if we would like to store strings, we have to say that string, and it's going to be a new array of strings. And basically so simple, but I'm going to store integers just for demonstration purposes. And what's very important, that we have to define that I would like to store integers, then I'm not going to be able to store integers and doubles and strings at the same times. Arrays are not so flexible in the sense that we have to define that, okay, I would like to store 5 integers, then I'm not going to be able to store 8 integers, I'm not going to be able to store strings or doubles or custom objects, I'm just able to store 5 integers. So we have to specify the size and we have to specify the type of the one-dimensional array. And basically, let's discuss the order 1, so constant time complexity operations. I can get, for example, a single number with the help of the indices. So I'm going to get the value with the index 0. As I said earlier, as we have discussed, the indices starts at 0. So for example, I'm going to iterate through the array I is less than the nums dot length plus I, of course nums. And basically I'm going to set the ith index to be equal to the I. What does it mean? That the 0 index, so the first item is going to be 0. Then the second item, where the index is 1, is going to be 1, then 2, 3, 4, and 5. I would like to get the number at the index 0. You may have a guess, then it's going to be 0. Okay, I would like to run as a Java application. It's going to be the 0. What about the number where the index is equal to 2, for example? It's going to be 2, and so on. So we assign I to the numbers of the ith index. So basically this operation, when we get an item with the help of indices, this is the so-called random indexing. It is very fast, and basically this is why we like arrays, and that's why hash maps and hash table relies heavily on arrays, because we know for certain that if we have an index, we are able to get the items with the given index in constant time complexity, so very fast. Basically, the disadvantage of arrays is the linear time complexity, so-called linear search. For example, I would like to find the item in this nums one-dimensional array where the value is equal to 4. Of course, we have to iterate through all the array, so I is equal to 0. I is less than the nums dot length plus I, and basically if the nums of I, so if the value is equal to, for example, 4, I would like to print out the index found and it is equal to the I. Okay, so if we run our algorithm, okay, it's going to print out 2 because of this, but we iterate through all the array. we're considering the first item in the array, the second item, the third item, and on every iteration we pose the question that is it 4? And basically when the index is 4, so basically the fifth item is the 4. So where the index is equal to 4, it's going to be number 4. Or maybe I'm going to add items, for example 2 times I, just to be clear that what is the index and what is the value. So of course the num2 is going to be equal to 2 times 2, so 4, and we iterate through all the numbers, and basically we print out the index where the value is equal to 4. And basically the index is equal to 2. What does it mean? Because the indices starts at 0, so that's why it's going to be the third item in the array. And it is basic math, so you can check it. So basically this operation has linear time complexity. We iterate through all the arrays to be able to find the item we are looking for. And basically this is why advanced data structures came to be. Because computer scientists posed the question that, okay, are we able to reduce the running time and the time complexity of this operation? And basically we are able to reduce this operation to ordo logarithm n with the help of binary search trees, so binary trees, and we are able to reduce this operation running time to ordo 1, approximately constant time complexity, with the help of hash tables. So basically this is the starting point that, okay, we have the linear search, we are looking for an item in an array, we are able to do it in linear time complexity. Can we do better? And yeah, we are able to do better constructing a binary tree. Okay, it's going to have logarithmic time complexity. It's better than the linear time complexity. It is faster. It has logarithmic time complexity. We pose the question again. Can we do better? We come to the conclusion that yes, we are able to do better. We can achieve ordo 1 constant time complexity if we use hash functions, and basically hash tables and hash maps relies heavily on hash functions. Okay, so basically this is how arrays work. We have to define at compile time the size of the array, then we have to define the type we are going to store, so integers. If we use random indexing, it's going to be very fast, but if we would like to find something in an array, then we have to iterate through all the array items one by one. This is the so-called linear search, and it has linear time complexity, as the name suggests. And if I would like to assign a value to the fifth index, for example, I would like to set it to be equal to 10, then Java is going to throw an error because we have an array with the size 5. Because the indices starts at 0, it's going to have the index 0, index 1, index 2, index 3, and index 4. The index 5 is an invalid index. We are not able to use that index because this is out of the range of our one-dimensional array. So this is the exception we are looking for, this index out of bound exception. We would like to insert an item to a wrong index because it is out of the scope of this one-dimensional array. So basically, if we would like to insert another item, first we have to iterate through all the items in this list. We have to create another array with size, for example, 10, and we have to copy all the values from nums to nums2, and we have to insert the 10 at the end of the list. So that's why reconstructing a one-dimensional array is quite complicated. It takes ordo and linear time complexity, as we have discussed in the theoretical section, and basically that's why we like dynamic data structures such as linked lists, for example, or binary search trees. We are able to insert and remove values in a much more dynamic manner. But on the other hand, we like arrays because of random indexing, and that's why hash tables relies heavily on arrays, because it's going to end up with the ordo 1 time complexity because of the random indexing. Okay, so that's all about arrays. Thanks for watching.